There we go. Okay, so this is page 32. This was what was to be your homework for the weekend. You were supposed to do these last two questions, one of which was super easy, and one of which, although easy, required some thinking. The first one is, of course, the cylinder. And the surface area of a cylinder, you, of course, remember, is two circles, 2 pi r squared, plus this part, which is 2 pi r h. Now, I want to make a point here. When you look on your formula sheet, which I gave you, you see that the cylinder gives you the top, the bottom, the side, and then the entire formula. That's important because sometimes when you're working out math problems in real life, you don't want everything, right? So it's good to know what part of the formula does what part of the question. So I like to remind you that this part covers the top and the bottom. This part covers the middle. Okay? Now, since this is not a real-life math problem, this is a math problem, we are finding the surface area of the entire shape, which means we are going to use the entire formula. And that just means we fill it in. 3, 2 pi, 8, 3. 3 squared is 9. 9 times 2 is 18 pi. Plus 8 times 3 is 24. Times 2 is 48 pi. And then, of course, because you have 18 pi's, yum. 48 pi's, yummier. You add them together to get 66 pi's. That is what we are looking for in the 10th grade and beyond. Okay, you do not need to worry about changing it to decimals, then asking me, how many decimal places do you want, Mr. Myers? Just leave it as pi. Okay? If that makes you go, ew, I can't do it, I need decimals, I must have decimals, give me my decimals. Then, of course, you just on your calculator do 66 times the pi button and then equals. Okay? And you get something like 207 point blah, 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 blah. Both of those are acceptable answers. As you go further and further in math, though, you're going to leave it that way.
Please excuse this interruption. Can we have grade 9, A to L, come down for photos? Just be aware that there are 2 cameras in the library and 2 in the rotunda.
But, see, that's the problem with that. Betty, when she did that announcement, just said there's 2 cameras in the library and 2 in the rotunda. Which means what she is implying is that when you go downstairs, if it's crowded in one of those places, go to the other. But that's not what happens because people are not intelligent. They see a big crowd and they go to where that big crowd is. Right? She needed to add that bit of instruction because once people are in a group, they do silly things. That's why guys who own nightclubs don't let people in. They keep a lineup out front even though inside it's empty because people are so dumb when they see a lineup outside a club, they'll be like, that must be a cool club, and they'll line up there too. And then you get in and you're like, my God, there's no one in here. I should have gone to that other club down the street where there were actually people that I could talk to and dance with. But no, here I am by myself. But what are you going to do? That's just marketing. Robert.
Hello.
Hello.
How are you?
I'm well, thank you. How are you? Good. So we have done that one. Now we move on to the paint question. Oh, this question causes so much grief. People have so much trouble with it. It kills me. Yes, many people didn't like this question. But part of the problem people don't like it, Prab, is because it's written in a way to confuse you. Yes? Because when you read this question, you can understand all the words. It makes perfect sense, right? I'm going to paint my living room. People paint rooms all the time. Excellent. I know how much space a gallon of paint will cover. Okay, I've measured my room. That makes sense. I got to know how much paint I got to buy. But then we get into trouble. Because the question is written, so it's a math question, isn't it? Because when you buy the paint, it tells you it'll cover 300 square feet. So, of course, how would you measure your room? If the paint is in feet, how would you measure your room? In feet. But because this is a math question, and I want to make you do extra math, how did I measure your room? In meters. That's kind of a dick move, I know. But it's a math class. That's what we do. So that's your first problem. The next problem is there's 3 dimensions to a room, right? There's a length, a width, and a height, yeah? Which are the dimensions that you need to worry about for painting? What are the dimensions that matter for painting? Here's a room, right? Right? There's the length, there's the width, there's the height. What are the numbers, the letters, that matter for painting? L and H, because you're going to paint this wall, aren't you? L and H, correct? And how many times are you going to paint that wall? 4? Twice, because there's this wall, and then it exists again back there. What's the other dimension that matters for paint? You've covered 2 walls of the room. What else do we have to paint? WH. Twice. Will we most likely be painting LW? Not necessarily. But if you did choose to add the ceiling in, you would then do LW. How many times? Once, because you do not paint the floor. The floor gets a floor. Okay? So this would have been times 1. If you did it at all. Did I say paint the ceiling? No. So if you painted the ceiling, did you still do it right? Yeah, of course you did. Because I didn't say not to. If you didn't paint the ceiling, did you still do it right? Yeah. Yes. Everybody okay with that? So depending on whether or not you added in the ceiling or not, your answers will be different possibly than your neighbors, yes? Do I care about the answer? No, of course not. I care about the work you did to get it, right? So, since we needed LH and WH at least, we all agree we needed to paint the walls, yes? Everyone agrees? Okay. So then, what do I need? 4.1 times what? 3. WH. Yes? No. You can't. Because we're doing math. And you can quickly call your dad in an hour when it's lunchtime. Then leave. No, you would have to go down to the office and call him from there. I don't care. Okay. And then that would multiply by what? 2. Then what's the next one I got to do? 2 times 5.3 times 3. But there's a problem with this, isn't there, Prab? This gives me what for answers? No. Sorry, what unit is it in? Meters squared, which is trouble, isn't it? Because the paint is in what? Feet squared. So you have a decision to make here. If I convert that and that and that and that to feet, now will I get the right answer? Yes. If I do this right now, which is 12.3 times 2, 24.6, and 5.3 times 3 is 15.9 times 2, which is 31.8, correct? Everyone agree? But those are meters. Here's where we get into trouble, and you had to think to do it right. If I don't convert those now, how do I convert meters to feet? Oh, Mr. Myers, you multiply by 0.3048, right? Do you? Why not, Wyatt? Because that's not the right answer. Yeah, you can't do that, right? Because meters to feet with 3048 is a straight line, isn't it? Isn't it? That 1 foot is 0.3048 of a meter, right? Except these are in what dimension? Meters squared, isn't it? So, if that square is 1 foot by 1 foot, what's the area of the square? 1, right? Because it's 1 times 1, agreed? So it's 1 foot squared. Cool? But if I convert this to meters, that's 0.3048 of a meter, isn't it? Everyone agree? It'll show up in a second. Everyone agree? Because that's 1 foot and that's 1 foot. They're the same distance, yes? So what is this side? It's also 0.3048, right? How would I find the area in meters in here? Multiply the two, right? So I would have to do 0.3048 times 0.3048 to get 0.0929. So this is 0.0929 meters squared. So if I want to convert feet to meters, I got to use those numbers. Does everybody understand? If I'm going squared. Now, could I have converted them back here? That's okay. And I would get the same answer. Is everybody with me? So if I convert those, then I can just use 0.3048. But once I multiply them out, I got to use this. Everybody cool? Right? So these meters, I want feet. Right? So I would have to divide these by 0.0929 by 0.0929. Everybody with me? And then what are you going to do with those numbers? What do you have to do with all the numbers? Add them up. And then divide by 300, right? Because the paint will cover 300 square feet. And this is going to give me square footage numbers. Is everybody cool with that? Right? I expect a great many of you did part of this wrongly, and that's kind of the point. Because once again, was the math difficult? It's convert two things, then multiply length times width, right? Add two numbers, then divide by 300. It's not hard. Yeah? But it was a hard question to do, wasn't it? If you even attempted it, which a great many of you probably didn't even attempt it. It was the weekend. Everybody cool? So who has some answers for me? Because I know what the right answer is. Somebody must have done it. How many gallons of paint did I have to buy? What do you have, Prab? 1 gallon of paint. Okay. You're pretty sure you did it wrong? All right. Would it have helped if you had done an estimate? Yeah, because then you would know if you did it wrong or not, right? Isn't a meter about 3 feet? Yeah. So wouldn't 4 meters be about 12 feet? And wouldn't 3 meters be about 9 feet? And 12 times 9, easy, that's 108, right? Times 2 is 216, yeah? Isn't 5 meters about 15 feet? 3 meters about 9 feet. 15 times 9 is 135 times 2 is 270, right? So 270 and 216 is 486. 1 gallon does 300. So I would need to buy 2 gallons of paint, wouldn't I? Then you do all the work, and you get a number like 75. Did you do it right? No. Picking up what I'm putting down? Is it worth 2 seconds to make an estimate? Because then you know about where you're going. Everybody get me? The point of this question was this. You had to convert outside your data booklet. Right? Because there wasn't a conversion on your data booklet for meters squared to feet squared, was there? So you had to figure that out, because that's what math is about in real life, right? When you're out in the real world and need to do something with math, is there a teacher or a textbook there to show you how to do it? No. Okay. Are you all able to multiply and divide with your calculator? Is that all there is to math? No. As a matter of fact, that's the least part of math, the numbers. Because everybody can move the numbers around. Everybody good? Does everybody understand what I did there? You had to either convert the measurements at the beginning and then do length times width and add it up, or you did length times width, added up, and converted the measurements at the end. I need to make sure you all understand that part of it, because that's the important part. Is everybody with me? Let me give you another example. See if you understand what I'm saying. 1 meter, 1 meter. Is everybody cool? Okay. What's the area of that red square? 1 meter squared, yes? Okay. What's the area of that red square in centimeters? If it's 1 meter squared, how big is it in centimeters? How much? You say 200. Why 200, Jasreet?
Because 1 meter is... Oh, wait, no.
Exactly. What did you say it is? You say it's 100 because there's 100 centimeters in a meter, right? Okay. Why do you say 400? Okay, so all of these are 1 meter. So you say it's 400. Okay, because 1 meter equals 100 centimeters, yes? So how long is this side? 100 centimeters, yes? How do you find the area of a square? Length times width, isn't it? So wouldn't it be 100 times 100? Right? Which is what? 1,000. 10,000, right? So 1 meter squared is 10,000 centimeters squared. Does everybody understand that? Conversions only work in one dimension, what you've got on your sheets. You have to figure it out if it's in more. Does everybody get it? Yes? Let me give you another one. 1 yard by 1 yard. How many square yards is that black square? How many square yards is it? Don't overthink this, guys. 1. 1 yard squared. You with me? How many square feet is it?
9.
Yes, because this is 3 feet and this is 3 feet. So this is 9 feet squared. Does everybody understand? What if I wanted inches? 3 feet is what?
12.
No, 3 feet. 36 inches. What would this be? 36 inches. So this would be 36 times 36, wouldn't it? They're all the same distance. Distance is the wrong word. They're all the same measurement because yard, feet, and inches are all the same. But you do not convert them the same way. Is everybody cool? Yeah? All right. Let's move along. Oh, we never finished the gummy bears, did we? Oh, well, we'll come back to them. So if everybody would be so kind as to flip to page 33 in your Outrageous Orchid books. We've spent 2.5 days now talking about surface area. And that last question shows you that even if you feel you understand surface area, you don't really, do you? There's more to it than length times width, right? If it was only length times width, we could have stopped teaching you math in grade 5, yeah? Because by grade 5, you've done everything that you need to do, yeah? But the world is a little more complicated than grade 5 math. So that's why we carry on. But now we're going to start spending a couple of days on volume. Volume is different again. Surface area is what's on the outside, yes? Volume is the amount of space an object contains. How much space in the universe it takes up. Which means volume is how many dimensions? 3 dimensions. Right? Now remember back on the very first day, we talked about how this was a prism, yes? The first day of this part of the unit, we talked about this being a prism, right? But what is this really?
A book.
Good answer. Now what is this really if I'm not looking for the wise-ass answer? It's that, right? It's a rectangle stacked on top of itself. Yes? Everyone agree? So that should tell you something. That should tell you if I take a 2-dimensional shape, which only has length and width, and I stack it up on itself, I can build a 3-dimensional shape. Yes? Now when I say stack up, do I mean up and down? No, I just mean cram together. Because if I hold the book this way, there's no up and down. Right? So, volume is a 3-dimensional shape. And we remember that these shapes are made up by repeating a base, put base in quotation marks, shape. Now, do I mean the bottom? No, what do I mean? What do I mean? The shape that repeats, yes? Base means the shape you repeat. And I'm going to show you what I mean in a second. Ow. Ow. Go for Myers. Yes. Okay. Bye. Sarah. At lunch, you have to go to the office. I do not know why. All right, so what I mean by this is you take a shape, like a rectangle, stack it up together, you get a prism, right? If I take a circle and stack it up together, what do I get? A cylinder, right? Everybody cool? Right? That makes perfect sense, yes? So,
at this time, if we could have grade 9s with the last name M to Z, please come on down to get your picture taken. And also, Emmanuel Petrescu, please come to the main office. Emmanuel Petrescu, please come to the main office.
okay, so what we have there with a regular one for prisms is we take a shape, like a circle, right? And if we found that area, then we would know how big the base shape is, yes? And then if I build that shape up and I multiply by the height, I get the volume. Is everybody good with that? Because I know this little yellow part takes up a certain amount of space in the universe, yes? And then the height is how many times I repeat that little yellow part. Is everybody cool with that? Now the problem, of course, is as soon as I say base and height, what do you automatically want to think of? Base times height, because of triangles, right? And we discovered that when we turn the triangles around, the base and height are just measurements on the triangle, no matter where we turn it, right? Same thing here. Don't get trapped in bottom and height. Do you understand what I'm saying? Remember this. Base is the shape you repeat, right? And h, which we always say equals height, is simply the measure from the base to the opposite side. Do you understand what I'm saying? If we built a cylinder to encase my body, it would have to come up this way, right? Like if we were doing one of those magic tricks where they bring the curtain down here and they drop the curtain and I'm inside the curtain, where would you say the base is? At my feet, because this is my height, right, Josh and Deep? Makes perfect sense. If I lie down, that circle is still what's repeating, right? So that circle is the base, but the height goes out across the shape from the base to the top. Does everybody understand? Okay. So everyone's cool with prisms, right? They're easy. Everyone agrees? Now, what if I draw, and I'm going to draw it in blue, instead of a cylinder, I make it a cone? You guys are smart kids. Would you rather have this cylinder filled with ice cream or a cone filled with ice cream? Why the cylinder? Because there'd be more ice cream in it, yes? So you guys already, just from looking at that, recognize that a pyramid must take up less space than its prism, right? And if you do experiments, you find out that pyramids are 1/3 the volume of their prism. So, what does that mean? That means that whatever volume you get of this cylinder, if I divided it by 3, I'd have the cone. Everybody cool? So, all of this brings us to these two things. A prism is always the base area. And remember, base is that shape times the height. A pyramid is always base area times the height divided by 3. Is everybody cool? Always. Everybody good? Okay. Now, please notice I want us to go back to the last 5 questions, which we did surface area for, and we're going to do volume for them. Everybody good? And that starts on page 26. 27. I'm the worst kind of liar. So you should have all left a little bit of blank space because you don't need much room. I left you a ton of space to do these questions. So here's where I'm going to block that off, and I'm going to put the volume. Is our cereal box a prism or a pyramid? It's a prism, right? Which means, since it's a volume, the volume of every prism is the base area times the height, yes? Everyone agrees? So the way I have drawn this prism, I've got a yellow rectangle, a green rectangle, and a blue rectangle. Could any one of them be the base area? Yeah, because if I make it the blue rectangle, then I repeated the triangle, or the rectangle that way. Agreed? If I make it the green triangle, if I made it the green rectangle, I repeated it that way. Agreed? If I made it the yellow rectangle, I repeated it that way. Agreed? So if I know any one of those three areas, and I multiply it by how many times I repeated it, I'm going to get the volume, aren't I? Does it matter which one I use in a rectangular prism? No, it doesn't matter in a rectangle. Hey guys, how's it going? Not a lot. What's up with you? You come to get your picture in this year's yearbook?
Yeah.
Nice.
Switching IDs again to get it.
You badasses, yeah. Because you want a fake ID that says you're still in high school.
Yeah.
Of course you do.
I got rid of mine, so I need to get one. Everything's good up?
Great.
That's good.
See you guys later.
Yeah, have a good one, man.
Yeah, if you're still around at lunch, drop by. Okay. So anyway, it doesn't matter what base area I choose. If I were to do the yellow one, what would it be? What numbers would I put in for yellow? L and W, right? Which we said were 8 and 24, yes? If I did blue, I would have to do W and 40. If I did green, I would have to do 24 and 40. And then I would multiply by the third number. Is everybody good? That's why the shortcut for prisms is just LWH, because it doesn't matter what order we multiply in. Everybody cool? So all we would do is do 8 times 24 times 40 and get an answer of whatever it is. It's 320 times 24. I don't have my calculator out. One of you can do that math and tell me what it is. Who has your calculator out? 11,000? 7,000. 7,680 watts. Centimeters cubed, because we got 3 dimensions. Does everybody understand the easiest kind of volume? The problem we make with this, the mistake we make when we're teaching this to you guys, is we give you this formula without explaining this part of the formula. Because as soon as you see that formula, you're like, oh, it's LWH, I got it, no problem. Because that is not a concept, is it? That's math. This is a concept. Is everybody cool with that? All right, let's go to the next page and see if you indeed are. Now this next question, again, you feel like you need a lot of room, but you don't. The lines will show up. So I left very tiny bit of room here on purpose. Is this a prism or a pyramid? Pyramid. So I know that the volume is the same as the prism, but divided by 3, right? So this is a rectangular pyramid, so it must be the same as a rectangular prism, but divided by 3, correct? So every prism we know is base area times the height divided by 3. Do we know the base area of this pyramid? What is the shape that is repeating? The rectangle. We started out that big on the bottom, and then we repeated that rectangle, getting smaller and smaller and smaller, didn't we? So, since the base area is the shape that we start with, I must need the area of this rectangle. How big is it? 32 by 48. And then we need the height, which is a straight line measurement from the middle of the base area to the end of the shape. Do I know that height on this question? Read the question. 65. And then, because it's a pyramid, what do I do with that answer? Divide it by 3. I just punch it into my calculator and I get it. Once again, if you don't get the concept, you're in a bit of trouble, right? But if you get the concept, it's so easy. It's a rectangle. Multiply by how many times I stack it up. Oh, but it's a pyramid. I'm losing shape, so I got to divide. What's the answer? I don't have my calculator going. What's the answer? Somebody in here has multiplied 3 numbers and divided by 3. 33,280 feet cubed. Is everybody okay with that one? Everyone's cool? It's pretty easy, right? Okay. Number 3. Is a cone a pyramid or a prism? It's a pyramid, right? So the volume of a cone, since it's a pyramid, must be, as they always are, the base area times the height divided by 3. But what is my base area of a cone? What's the base shape in a cone? Circle. So what's the area of a circle? Pi r squared times what? It's right here. Times the height divided by 3. What's the radius of this circle? 15 times 22 divided by 3. Do that with your calculator. What's 15 times 22? No rush. We're not in any kind of rush. Make sure you get it written down. What is it? Pardon? Yep. So it's 330 pi over 3, correct? What do you do with that 3 now? Divide to get what? 110 pi what? Centimeters cubed. Are we allowed to leave it in that form? Yes. Is that what we want? Yes. If you were to change it to numbers, you just do 110 times pi, right? Okay. Now let's do the last one. The volume of a cylinder. Is the cylinder a prism or a pyramid? Prism, because it doesn't come to a point, right? And every prism is base area times the height, correct? But since it's a prism, do we divide by 3? Nope. What's the base area of a cylinder? What's the shape a cylinder starts from? Circle, so it's pi r squared times the height. What is it? What's r? 5. And what's h? $20. So we write it out, 20. And then we just do the math. 5 squared is 25. So I got 25 pi times 20, which we know is what? 500 pi centimeters cubed. Is everybody cool with one shape easy ones? Everyone's good? Yeah? Okay. On this page right here, I don't want you to do anything. I just want you to talk about it for a second with your neighbor. What would you do? You don't need to do it. What would you do to tell me the volume of that? Don't do it, just talk. I want the volume of that shape. Come up with a strategy to tell me the volume of that shape. Go. Don't all talk at once. It won't be loud and hard to think. I'm serious. Talk to each other. Tell me the volume of that shape. Don't tell me the number. Tell me what you're going to do to get that number. Yes. What would you do? You don't know? You have no idea how to solve that. You can't think of any way that you could figure out the volume of that. Okay.
Last call for any staff or students that haven't had their picture taken. Please come on down to the rotunda. That's last call for all staff or students that haven't had their picture taken. Please come on down.
All right. A lot of people had something to say. A lot of people said they had no idea what they would do. Would anybody like to volunteer their strategy? Remember, I don't want the numbers. Just tell me what you were planning to try. Daniel.
Separate like the top part from the bottom part,
Okay.
and then find the volume for each one, like individually,
Okay.
and add them.
So Daniel says he would take the bottom prism, which is LWH, because it's a rectangle, yes. And then he would take the top prism, which is LWH, because it's a cube, and then add them together. Is everybody happy with that? But what about overlaps? Don't you need to remember overlaps? Do you need to remember overlaps? Why not, Rihanna? Because surface area, you lose overlap, don't you? But not in volume, because volume is the amount of space inside something, yes? Surface area of this is one hand. Surface area of this is a second hand, yes? If I put them together, I lose that surface area, yes? Volume of this is what? One hand, cubed. Volume of this is what? One hand. If I put them together, did I lose any volume? No. So overlaps are out the window. We don't care about overlaps. Is this a perfectly acceptable answer? How many of you would have done that? Okay, perfect. Excellent. That will work easily, often. Everybody cool? All right. Let me ask you this. Is this shape, although it isn't regular, is this by definition a prism? Remember, a prism is a shape that repeats. Is this a prism? Why?
Because there are different classes. Like, there's the one on the top, and there's the rectangle. So if you separate the rectangle, there are three boxes.
Okay. So Daniel is saying it is a prism because you can cut them that way, right? Okay. What if I did this? What did I just color in when it shows up? Doesn't that shape repeat? Doesn't that, your favorite Tetris piece, because of course it is your favorite Tetris piece, because it's far and away the best piece in Tetris. If that shape repeated, would I not have the back? Wouldn't I? So since we all agree that this is a prism, because the shape repeats, isn't the volume of every prism base area times height? Isn't it? So if I could find the area of that green and multiply by 4, wouldn't I get the volume? And will that work with every prism? Yes. Does everybody see what I have done there? If we do Daniel's method, which is perfectly acceptable, 12 times 4 times 4, correct? So Daniel's method, which everybody agreed with, was 12 by 4 by 4, right? Plus, up top here, was 4 by 4 by 4, yes? 4 by 4 by 4. 4 times 4 is 8, 8 times 12 is 96, 4 times 4 times 4 is 64. So the volume is 160 millimeters cubed. Agreed? Everyone agree? Now check my method. How big's the green area? Well, this is 12 by 4, right? Right? So that's 48. And this is 4 by 4, right? Right? What's 4 by 4? 16. Yeah? Right? So what do I do with those two numbers? Add them up to get, what is it? 64 times 4. What happens there? $256. Hey, wait a minute. What happened? Why didn't that work? Because it should have worked, shouldn't it? Didn't we do the area of the base times the height? The 96 is wrong. Why is 96 wrong? What did I do? Why? What did I do with 4 and 4? I said it was 8. What's 4 times 4? 16. Does everybody see what happened there? This is a mistake that you guys make all the time. Right? I added that. Okay? You can't do that. You understand what I'm saying? The math is easy, but you can't make mistakes. You have to remember it's times and times. Now, you picked up on that. There's a point. That's why I did it. Because this way should have made no sense to you. Because it was too small. And when you check it with what does make sense, it's going to work out. Everybody good? I want to show you one more. This shape right here. What if I told you I wanted the volume of this? Could you find this volume and add them together? Would that be okay? Okay. Could you also find this area and multiply by 3 for the up and down? Because doesn't that green repeat downwards 3 times? Is everybody with me? That's the point I'm trying to make. You have to be aware that it doesn't matter what we do. You don't have to do any more work. Over here, what would be the shortest way to find this guy's volume? What would be the shortest way to find his? The least amount of work. Is it a prism? Is it a shape that repeats? What's the shape that repeats? That, right? So does that make that the base? And what's the height? 15. So if I know that yellow area and I multiply by 15, do I get the volume? Is that easier than trying to find this volume, then adding together? Depends on what you think. I know some kids that have sat through my class and they see this, they're like, that makes no sense to me. I have to do volume 1 and volume 2. Is that okay? Yes. Always. Is everybody with me? So what about this one? Again, don't do it, but let's talk about it. How would you do G for volume? What would you do? Talk to your neighbor. Take a moment. How would you figure out G? Because G gives you another way you could do it. Does Daniel's method work here? Can we cut this right there or right there and do volume, volume, and add? Okay. Does my method work? Could I find this area and multiply by 6? Because that's the base area, isn't it? And I repeated it 6 times. Could I do this? Find the whole thing, 6 by 4 by 22, and then subtract out that little one. Does that way work? Is any one way better than the other way? No. Does it help to know all 3? Yes, because sometimes you might want to use base area times height. Sometimes you might want to do the subtraction thing. It depends on the shape you're dealing with, correct? If I gave you something that was really, really ugly, like this, and said that was my prism, what would you want to do? Would you want to find volume, volume, and add? That's pretty ugly. Could you subtract? That's pretty ugly. But if you could do this guy, and you knew that it went back 7, then that's real easy, isn't it? Everybody with me? Again, nothing new. It's just the regular shapes that you already know. So your job right now, when my computer wakes up, is 2 things. One, we haven't talked about spheres yet. We're going to skip spheres for now. We're going to come back to them tomorrow because we lost class time today to pictures. You guys are going to go to page 35, and you're going to do number 1, number 2, A and B, and that's it for right now. Let's make sure you are in good shape before we go on and add spheres to the mix. Okay? So you guys do 1A, 1B, and 2A and B right now in class before we go any further. So, it says it's a square pyramid. So do we have a formula for it? Yeah, if you look on your sheet, the surface area is B plus 2B times slant, right? So we just fill it in. The B was 6, so B squared is 36, and the 2B base times slant. 6 times 8 is 48, 2 times 48 is 96, and we add them up. Did anybody have a problem with the surface area? If you did, the problem that most of you have is you do this, you say it's 36 squared. It's not. It's just the 6. Everybody cool? Is everybody okay with that one? Okay, now, volume, we know since it's a pyramid, I got to divide by 3, don't I? Right? So that covers that, but I also needed the height. There's a problem there, isn't there? Because we only have the slant height, don't we? So how did I find out the height? I remembered this. I know it's 8 up the side of the pyramid, and I know the whole bottom is 6, yes? But I can't use the whole bottom because I need the height goes up from the middle, right? So this is how far? The whole bottom was 6. So this is 3. And then I use Pythagoras. Since I already had the hypotenuse, it's a subtraction Pythagoras, yes? 8 squared 64 minus 9 is 55. And then I square root the answer. Now, why did I leave it like this? What happens when I square root 55? I get a yucky decimal, don't I? So what I like to do here is I like to leave it as the square root of 55. And here's what it would look like. What is 6 times 6? So this equals 36 square root of 55 divided by 3, yeah? What is 36 divided by 3? 12. Right, it is 12. So this answer is 12 square root 55. Then I don't have to have any yucky decimals. Everyone cool with that? It just saves you calculator work. If it's going to be a yucky number, you can just leave it like that. Everybody good? No tricks there, right? It's all math you already know. Formulas, Pythagoras, multiplying, adding. Everybody cool? All right, let's look at the next one. Surface area of the cone. Surface area of a cone, that's a formula we already know, right? Pi r squared, pi r slant. Did I have a slant anywhere? No, so I had to find it. So I say to myself, self, that's what my cone would look like. The radius is 15, the height is 25, so now I need the slant. So I did that right here. And it's the square root of 850, which is going to be a yucky number again, yes? So I just leave it like that. Is everyone okay? Now, if that bothers you, of course you just do that on your calculator, don't you? 225 times pi to get a decimal, plus 15 times the square root of 850 times pi to get a decimal, and then you would add them together. Everybody good? And then for volume, since a cone is just a pyramid, base area times height divided by 3. Base area of a cone, pi r squared, times the height 25 divided by 3, and that's what we get. Could everybody do those first two? Because there's no tricks there, right? It just looks different than what you're used to seeing. Everybody okay? All right. Has anybody done 2A? Okay, carry on. Just about 2A for a second, as people are going to be having trouble with 2A. Half of you are going to have done it wrong. Half of you are going to have missed the trick. Even if you did it right, you probably used some wrong numbers. So let's talk about it for a second. A triangular pyramid. If it's a pyramid, what is every volume? Base area times the height divided by 3, correct? Everyone agree? Okay. So it says it's a triangular pyramid. So if it's a triangular pyramid, what shape is its base? A triangle. All right. So I got a base that's a triangle, yeah? How big are the sides of that triangle according to the question? 13. Excellent. How do you find the area of a triangle? No. Base times height divided by 2, right? Well, the base is 13. What's the height? No, that's the height of the pyramid. What's the height of that triangle? Oh, now I see why this is a math problem. How do I find that red line? Pythagoras, your best friend Pythagoras, which is the square root of what? 13 squared plus or minus? Why is it minus? Because I have the hypotenuse. Minus what squared? No. What? 6.5 squared. To get that height. Now you should be able to solve this, right? That was the trick there. Is there a trick in B, or is B straightforward? Does B have a trick in it? Or can you just use the formula, which is volume of a pyramid, base area, times height divided by 3. Can I just use that? Do I need Pythagoras in B? No. What if, Prab, the question gave you, said, and a slant height of 15? Would I need Pythagoras? Yes. Everybody good? Okay, so you can finish them off tonight or today. I'm going to finish them right now and tack it on to the end of the video so you can check your work tonight. Perfect timing. Yes?
Can I use your microwave?
Please do.
Awesome.
See you. Please do.